Because we are about half an hour late.
Yes.
Not exactly,
Almost 20-25 minutes.
ठीक है चलिए
आगे ना
बस सर 1 मिनट और वेट कर लेते हैं लास्ट हेलो हेलो
ऑनलाइन हो रहा है सर एक्चुअली पार्टिसिपेंट्स काफी ऑनलाइन भी है ना तो
ऑलरेडी ऑनलाइन हो
वो चेक करना है
ना हो गया चेक कर लिया
सारे कह देना मुझे कर स्ट्रीमिंग हो रही है होगी थी
ग्रुप के ਵਿੱਚ ਮੈਸੇਜ ਪਾ ਦੇ ਆਪਣੇ ਨਾ
हाँ हाँ मैंने कर सर बस 1 मिनट
ऑनलाइन में पार्टिसिपेंट ज्वाइन कर लिया
यस सर 12 participants in the group
सर ओके यहाँ से आ रहे
क्लास में तो छोटा है आवाज आई थिंक कैन इजीली ऑडिबल
हाँ नहीं वो सर नीचे था ना इसलिए यहाँ तक किया एक बार चेक कर ले बस कई बार कोई दिक्कत
जरूरत नहीं वैसे स्पीकर की
अगर
ओके
नो प्रॉब्लम
सर को फोटो जब सही नहीं आ रही है सर यहीं पे आप होंगे या वहाँ जाना चाहते हैं
ना कोई नहीं हम जहाँ मर्जी जाए
ये कैमरा उस हिसाब से चल रहा है
नहीं ठीक है फोटो
एडमिट करना
एडमिट
क्या एडमिट कर दो
एडमिट है सर नीचे कॉल आई
ना स्टॉप शेयरिंग तो नहीं किया है
हाइड कर दो हाइड कर दो
बट स्क्रीन तो शो नहीं हो रहा है
वही तो देखो वो खोलना पड़ेगा अटैच स्क्रीन क्यों होगा
ना खुला तो ठीक है
ओके
okay now good morning once again and we can start the first session of your short-term course. So here I want to first introduce about you people regarding the present scenario of manufacturing processes. So first I am going to discussing about the what are the innovation or inventions and advancement in the manufacturing. So first I am going to discussing about the what is manufacturing first from basic grassroots to come into within 15 to 20 minutes come to the advancement and then going to the discuss about your additive manufacturing. So basic definition of the manufacturing, that manufacturing involves process or processes to convert the raw material into products through product design. Many points I have included over here, and the same definition I have put in my textbook, that is the selection of raw materials, product design, selection of raw material, process planning, utilization of special technique, tools and tooling system, jigs and fixtures, etc. Product to be manufactured satisfactorily with economical. That is the most important point over here. One is product design. Second point is selection of raw materials. Third is process planning. Fourth is utilization of special techniques, tool and tooling systems. Tool, whether it is a machine tool, whether it is a cutting tool, and what is the tooling system. So how you can understand, I don't know whether what is mean by the tooling system. So let us, I given you one of the examples, very simple. Say if you want to use a circular tool, have an idea about the circular tool? Tool, you people have an idea in the simple single point cutting tool, multi-point, double point cutting tool. Single point simple turning and double point drilling, and the multi-point maybe a milling cutter. But once I talking about the circular tool, we need a special attachment called tooling system. Total tooling system is required. One in that cases will take the power from the rotational motion of a job. The tool will rotate in the opposite directions. So thereby the contact surfaces is continuously changes throughout the circumference of the cutting tool. So that of the things can be utilized. So we can eliminate the continuous heating, continuous friction by touching while removing the material in the form of chips. Clear? So these are the things are the important aspects in the development to improve the machinability quality. Simply if it is talking about the machining. So at the same time, product design, product design also again is a very brief thing. It is a long term. So first you have to create some idea. That idea you convert into a small sketch, simple sketch with pencil or pen. Then sketch convert into the drawing. Drawing means is required to the dimensions, put to the proper tolerance, actually engineering drawing. Then it is become, once you drawing prepared, then you require to be process planning. Root, what are the root sheets? You have to make out. When you are going to make out the root sheet, you need to the raw material schedule. That means what are the exactly raw material. Then once you going to raw material schedule, is required the raw material specification. What should be the specification of the raw material? Then quantity of raw material is required. Then you one by one operations is required to be involved for making into this. So therefore, then once you manufacture it, then you test it properly. Whether fabricated or produced part or component exactly fulfill the purpose. So therefore require a feasibility test. And once the feasibility test will getting a very good result, satisfactory result, then you claim you developed a product. I think you understand. A lot of steps are behind in the product design. And then development, process planning, utilization of technique, which technique will be the better and optimal, which require the minimum time, minimum cost. So that one word is here with economical and get up, attractive, no irritation, clear on the surfaces. That is also one of the important aspects. I think you have sensitive, hai na? Anyhow, so this is from the definition I have written over here last para. So what are the basic things have to be concluded. So this is become the manufacturing process. Next is one I want to just explain very simple thing. Say okay, manufacturing process is definition. So then there have been basic two parts. Part one is the factory physical activity, which is inside the factory, and another outside the factory. You should have a very clear idea about it. तो आई थिंक यहाँ रखेगा तो ठीक है, हाँ इससे करते रहे तो ठीक है, हाँ ठीक है, ओके ओके ठीक है ठीक, ओके फाइन. So then there is a inside the factory. Inside the factory, this is there have a lot of works I have given into the flow diagrams. So first you see raw material into, and then your processing pipelines. You can, if you consider the simple pipelines, you will see here material handling and storage, then process operation, then stage inspection. Every stage is required to inspection, whether the product is properly manufactured or not. If it is not, then you will able to understand here. Say then, because next operation is not required to the worthy in that cases. So that is stage inspection is most important. Next is because process sheet, you know, there have some columns are there. हमको लग रहा है ये आपका
यूएसबी खोल रहा है,
हाँ
यूएसबी खोल
ना इसको क्लिक
दो 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 मिनट कॉपी किया था,
जी डेस्कटॉप पे कॉपी है.
कॉपी वाली खोलोगे ना,
ना ये कॉपी वाली नहीं है. अच्छा थोड़ा देन
एक सेकंड, वो कॉपी के कारण ना वो खो रहा है, ये वाली खोल
ना वो नहीं, ये दूसरा, ये तो फर्स्ट पार्ट, इसको कॉपी कर दो.
इसको कर लो.
हाँ इसको कॉपी करके डेस्कटॉप में दो.
ओपन है.
ओपन है इसलिए वो सर और एक बार यहाँ ये क्लोज करो उसको, हाँ इसको क्लोज कर दो.
कौन सा वाला,
ये वाला नंबर 1,
ये वाला.
हाँ हाँ
सोचिए मुझे दोबारा
एक बार निकाल के लगा.
दो बार खुल गया ना, दो बार क्लिक कर दिए, दो बार
नहीं मैंने नहीं क्लिक किया, वो अपने आप ही खुलता था.
अभी एक बार खुल जाता है,
खुल गया.
बस एक बार हो गया.
अब इसको हम निकाल ही देते हैं,
हाँ इसको निकाल, हाँ
इसको
ठीक
निकाल के यहाँ रख देते हैं. आप बताइए ये वाला वन, ये वाला ना,
हाँ ये वाला खुल, ये वाला खुल.
शेयर है.
कोई बात नहीं, पता यही है ना,
एंटायर
इंटायर स्क्रीन पर
इसकी
क्लोज कर दो. ये बात ठीक है ना, हाँ ओके ठीक. So then here just I want to explain what are the operations involved inside the factory. Clear? So then even product is produced, a finished product for the sales office, and others will become scrap, and rejected part will become returned back, and like this way. Very simple thing I am just explaining here. And next part is this outside the factory. There is a lot of things are there. Outside the factory, there have again is a product design, then you manufacturing process planning, then inspection and quality control, then management function. These are become completely surroundings. This is also given in this book very clearly. So their product design I have already explained about it, the concept of idea, then generate sketch, engineering drawing, raw material details, bill of material and store, then product development. These are the every stages are involved here. And then here manufacturing planning, say process planning, raw material schedule, and drawing details, master schedule, capacity planning, requirement planning. One thing is drawing. Say once you make out the drawing, engineering drawing, after that might be manufacturing, some modification or some alteration is required. So that is also very clearly indicated in the drawing, whether alteration 1, alteration 2, and what should be the alter That should be very clearly indicated in the drawing so that operator easily can understand during the manufacturing. Second thing, requirement planning, capacity planning. Again, I think this is, I am not going to be explained over here. Then next is inspection and quality control. That is quality control planning. Inspection of raw materials. Whatever may be the raw materials you are using, that is properly as per the specified process sheet or not. Clear? Second thing, store of raw materials and finished product. There are different sort of stores are there. So then where it will be kept, from how it will draw it, what are the color code, and everything you should have the very particularly clearly understood about this color code also. Then shop floor control, quality control, then inventory control. There are different controls aspects are there. Then management function, one is the customer commands, order entry, sales, customer bills, packaging, delivery, and warranty, servicing. Lot of things are involved surrounding this, outside this factor. Why I am telling it? Because everything is involved with the manufacturing process. That's why I am coming one by one, you see. So that basic needs of development of the manufacturing process. What are the needs? Before 400 BC, gold, copper, iron, that is only hammering process. Today Director Sir is also explained about this. Now again 4000 to 300 BC, you see copper casting, stone and metal mold, just like a stamping, jewelry cases. And after that, bronze casting, cast iron, cast steel, then you see zinc, then steel, then blast furnace, casting of bales, then permanent mold casting, blast from copper and metallic zinc, then centrifugal casting, Bismarck process, nickel powder metallurgy, open hearth steel, open hearth furnace, steel is manufacturing used for this, then die casting, then lost wax casting or casting process, then ceramic mold, modular iron, semiconductors, sequence cast turbine blades, vacuum casting, rapid solidification technology, metal matrix composite, semi-solid metal casting, rapid prototyping in the year of 1970 to 2000. So that 30-40 साल पहले already it has been introduced, the rapid prototyping. Then rapid casting, rapid tooling, that is in that cases was developed simultaneously with precision technology, precision engineering, isothermal forming, even your super plastic forming, even the 90s, and that their micro casting, micro machining, and many things has to be already introduced. Then year 2000 to 2010, additive manufacturing, stereolithography, nano finishing, micro manufacturing, micro fabrications, they are 3D printing, abrasive flow machining, abrasive water jet machining, abrasive flow finishing, electrochemical spark machining, travel where electrochemical spark machining, lot of advancement has been developed by the researchers, clear, and the scientists. 2010 onwards, the micro and nano fabrication, miniaturizations, that is the small miniature parts in the micro and nano level. So hybrid machining and system, electrochemical grinding, and many more. Electrical emission machining, and a lot of things has been introduced. So now, you see here, 4 are approach here in that case, then after that 6 are approach. So approach here from 1975 to expected 2055 of this year. So initially you are conventional machining, then it will become lean manufacturing, then it is green manufacturing, then sustainable manufacturing. Sustainable manufacturing, there have a 6 are environmental control, utilizations of recyclable and bioabsorbable materials. Here, innovation in this manufacturing, first is reduce. What are the reduce? Reduce the cost, eliminate the wastage. Purely, not only reduce, eliminate the complete wastage, Kanban, just in time, and then reuse. Whatever may be, no wastage are there. That is, you can say scrap, but not wastage. Scrap can be reused. So reuse, recycle, recovery, redesign, remanufacturing. So these are the things That is, lean manufacturing of that time was zero waste concept. Conventional manufacturing provides substitute to the society, and lean manufacturing zero wastage concept. So, why lean manufacturing of that time basically was initially, say, conventional old thinking was cost plus profit, then price, decided the sales price. But new thinking is decided first the sales price. That is, price is first fixed, you decide. Then you should decide as a competitive market. Once you decide it, then you have to reduce the cost as much as possible. Then you can earn some profit. So that is become the key profitability in the cost reduction. So therefore, key area is to reduce the cost. So lean manufacturing is a variation on the theme of efficiency based on optimization of flow. It is present day instead of recurring theme in human history towards the increasing efficiency, decreasing waste, rather eliminate waste, and overcome the pre-existing idea. Then environmental impact of the manufacturing also you have to consider side by side. Say manufacturing process, one is output emissions, one is greenhouse gas, various pollutants, toxicants or solid waste, obviously will be this. That impact on the global warming, then acidification, human toxicity, and the ecotoxicity, and many more. Because of product and some of the byproducts are there. With the some require some energy input, with some materials. So just like given you one of the examples, say electrical discharge machining process. Here in that cases inputs are, you see, inputs are power, gap voltage, discharge current, pulse on time, pulse of time, all are the parameters and others, dielectric fluids, electric fluid levels, and workpiece. Now your output here, material removal rate, tool wear rate, and whatever may be, dielectric consumptions, processing energy, overcut, taper cut, these are become the your, you can say, the responses or characteristics on the machining. Now, what are the hazards or wastage and limitation? Hazardous gases, whatever may be the gas is due to dielectric media is become burned out or fumes or become generated. Filter cartridges, low material removal rate, wastage of dielectric media, dielectric slag, and insufficient power supply, poor surface finish, skin and lungs problem, basically electrochemical machining process or hybrid or electrochemical discharge machining process, hybrid process. So therefore it is required to rectify it. So when you are going to talking about the advancement in the manufacturing, you should have to take care about the your process which should not be environmentally hazard. So that green manufacturing idea for substitute in the manufacturing process, which leads to reduction in the energy consumptions, most important, energy consumptions, resource consumptions, waste by uses consumptions has to be reduced. If you more water consumption, water will not be available in a once upon a time or one day, and energy if you use this. Now at the same time, what are the needs of green manufacturing is a renewal of production process and the establishment of environmentally friendly operations within the manufacturing field. Second thing, needs are customers are environmental conscious. Environmental protection is a top agenda for everyone. What are the reasons behind it? Running out the fossil fuels, energy crisis, global warming, dissipation of ozone layer and depletion of ozone layer, loss of trees and forest. That is most important. Green manufacturing is become a challenge today, but as business opportunities for tomorrow. That's why green manufacturing people have accepted of this in the advancement. But the lot of terms are there: green, clean, environmentally conscious, then environmentally begins, and then environmentally responds, then eco-friendly, then sustainable. So lot of terms that people have used, and day by day have become researchers introduce the term and accordingly accepted the society for manufacturing to protect the society and better environment. So here I want to show you what are the difference here, lean manufacturing and green manufacturing. What are the common things? Waste reduction, value added, supply chain scope in the management point of view. But here, green manufacturing, you see, the key performance indicator is carbon monoxide and carbon dioxide, which is become usually generated or discharged with the byproduct or otherwise directly to the atmosphere during the manufacturing of some product from raw materials. That is become the key performance indicator which is required to be protected. Whereas lean manufacturing key performance indicator is cost. Only reduce the cost by any law. That was the basic idea. But in the sustainable manufacturing, non-polluting, conserve energy and natural resources, and are economically sound and safe for employees, communities, and consumers. Say some consumers purchase something product, after that using few days in the skin has been damaged or become irritation in the skin. So that is not acceptable. The people will not attractive about this particular product. So therefore that is also another important point. Next is, so performance indicator for sustainable manufacturing is manufacturing cost, energy cost, quality of the product, production efficiency, productivity, technology, supply chain worker or network. Then environmental performance is also involved, that is material and waste uses, energy consumptions, water, land and air pollution, restricted waste generated and emission released. Then social performance, health, happiness, education, poverty and standard of living. Everything is become a performance indicator in the sustainable manufacturing. That means sustainable manufacturing, you consider have to these things as well as. So then key 6 factors for achieving this sustainable. One is optimize your current use of the fuel. Second thing, eliminate waste. Third thing, reduce and eliminate the pollution. Fourth thing, recycle. That material once used, then it is required to recycle. Otherwise, it will become a wastage, and one wastage it will become store. Require store yard, require, that is a lot of things from the store material, many days of dumping on a place. So next is recovery energy, and that energy don't turn into the heat. You should also take care about it and save time. So everything associated with the cost. So then step are, they are developing work practice and maintenance. Second thing, process optimization. Third thing, raw material substitute. Then new technology and new product design. So what should be the product? What should be the material you can replace on existing, and you can change the shape on existing. So you maybe it is a very small, compactable and miniature micro level or miniature dimensional shape and size with attractive, then you can keep in your pocket but can serve the all purpose. That type of product is required nowadays without hampering the or without discharging any the performance indicator like carbon dioxide, carbon monoxide or other unhealthy gases or otherwise impurities into the society. So key energy, whatever may be the main key energy, that is consumption of energy, cost, waste. So personal health and safety is one of the important points here. That means as well as recycling. During the recycling, that is personal health and the safety of the society, of the human, of the animals, as well as tree living things should be taken care while you advance of the processes. So, but the question is there, in the year even 2060, I am planning of this, that is, and showing in this book also, textbook, the consumption is like this way, you see, consumption rate. Today's sustainable rate is this, sustainable capacity is this, but they gradually require to reduce the consumption rate to reach the sustainable capacity. You have to reduce it, but the demand is continuously increasing, future consumption rate. So gap between the maintain with the required rate and reach sustainable rate of capacity. So consumption rate increases, they are increasing of population. So their demand and efficiency of the manufacturing has to increase. So that can possibly to balance and can satisfactorily allow to live to the future generation by creating of the very good atmosphere and society. That is the most important. From this graph you can predict what are the in future possibilities. So why I am talking about there, you see the density of population in the megacities and their demand. What are the demands? In 1950 you see their simple, you see London, Calcutta, Singapore, China. I am showing here in the case of Calcutta in India there are 4.5 million of people. Whereas 2010 it is 15.6 million of people. More than 3 times within this period. And then 2025 expected it is to be 20.1 or more. So therefore gradually increasing, and the more people comes to the city, not they are interested to stay in the village. So about 7 out of 10 total population in India is coming in towards the city. So therefore their demand is too much. Their expectation, what are the expectation? General expectation, high degree of reliability, efficiency and sustainability, not only of the structure but also of the whole system, and high security of the infrastructure, particularly when subjected to extreme and unconventional condition. High security they want, and full integration of all the function of the system. Next, continuous health and integrity monitoring, that is health and integration. Should be everybody should got a very good doctor, medicine and all this. Next, damage detection and self recovery. Yes, detection very good. And then at the same time, intelligent operational management system. So that can be possible to make by developing of the smart technological prospect. New sensing, material and device, then required development. Second thing, new actuation of material and device. Next, new control device and technology have to introduce. Then self-detection. Yes, people itself can detect self, and self-diagnostic, self-corrective and self-control function of smart material and system. So that some of the smart materials, some of the systems, some of the part, your engineers have to develop, have to manufacture, have to supply to the society at a very low cost, so that society can at its purchase and can use to detect any problem or health issues and identify the problems, diagnose the problem itself, and can use the medicines accordingly to make perfect and healthy. So that these are the requirements with the population. Okay. So that people then thinking, yes, okay, going to this, introduce the manufacturing 4. Today's have your Dhillon of Dean Academic says. So manufacturing 4, I am again expecting, that is also given in my textbook. So that is in the new edition, I have given this everything. 850 pages of books I have given everything. What is the future prospect? And what is the requirement today? So here I am expecting 2000 by 30. That should be implemented so that we can. So first is advanced composite, ceramic, bioabsorbable and smart material. Nowadays, at present, one of my PhD student is working, stand. Why he is very much interested? His father was died due to heart attack, and attack in the stand in timely cannot changes because he was in the remote from Haryana villages. So that he came to me, sir, I want to do my PhD under your guidance and I am going to this. Now we have successfully developed and patented this particular stand using the zinc alloy with magnesium, zinc, magnesium, iron, clear, even silver. We can develop a metal and make your stand properly with micro machining process and as well as your some extrusion process through development of the set of one is powder metallurgy. First we have to make into the powder, then we use in the powder metallurgy process, compacting, sintering, and then extrusion of that particular making into small diameter, say 235 microns of hole only. The augmented reality. Augmented reality means reach maturity level and motive 200 microns of diameter with a 50 microns of hole. That is very difficult even in the CNC machine. So 3D printing, fuse deposition modeling, selective laser centering, and many of the process I have here explained over there. So these are become the important thing. Generation of 3D model, computer aided design and aided manufacturing. Yes, all that type of this is become already existing and old. Now we need the CAGs, CAX, clear, agile manufacturing. So even e-manufacturing. So these are the advancement, how it will become possible. Next is cyber security, because this is again another important point. Connectivity created high risk and exposure cause of cyber attack. That is another important now hackers to protect against the hackering. So wearable level or location, then personal data, many hack and hackers may generate threat. Strength of security, increase the security criteria. Next is micro, nano fabrication, nano engineering. Lot of things are required. Liga, then stereolithography, chemical vapor deposition, physical vapor deposition, polishing, etc. Then AI, artificial intelligence in the manufacturing, in machine learning, productive maintenance, diagnostic and predictive, etc. importance are also introduced with the manufacturing. Then double IoT, that is also in the manufacturing. That is communication and data sharing in smart industries in between the engineers and management. Smart manufacturing can be possible to introduce completely by this year. Manufacturing technologies, what are the development? You see, first the production line automation, that is mass production initially. Then it will become rises to the flexible manufacturing, that is group technology, CNC, robotics, clear. And then computer integrated manufacturing, CAD, CAM, direct numerical control machine, robotics, etc. are introduced in the manufacturing scenario, and can the so-called people says the computer integrated manufacturing. Next is lean manufacturing. I have also explained the quality control, Kanban, engineering tools, and many things. Then just-in-time manufacturing, say total quality management, material requirement planning 1 and 2. I think clear what exactly required. So I given you one of the examples, a very fantastic example. Say that if you want to make a hexagonal headed bolt, what should be the material you will select? If you want to hexagonal headed high tensile bolt, simple. That practical knowledge must have to be student have required. Anyone have an idea? Hexagonal bolt, high tensile bolt. High tensile means that should be 88 Newton per millimeter square of tensile strength. But no material we have of such the tensile strength. We have a steel maximum 42 Newton per millimeter square. How to enhance this? How to make the bolt its head? If it is a shank diameter 50 millimeter, so this across corner should be 2D is thumb rule, so 100 millimeter. If you take the 100 millimeter of bar, then you are going to turning for head is 0.8D, otherwise the shank length is 100, 150, 200 millimeter as the case may be. Clear what I want to say? So how you will wastage the reduction? How will this, what process you will consider? So in that cases we will take the 50 millimeter. Now you have the very much clear idea about the Indian standard organization based commercially available raw material specification. You must have to be very clear idea. Clear? Say as per bar 12 millimeter, 16, 20, 22, 25, 32, 36, 40, clear? 46, 50, 56, 63, 70, 80, clear? These are becomes available up to 120, 110 and 120 and 100. So this is become the standard commercially available as per Indian standard raw material specification. Now the question is again, so then if I selected the 50 millimeter diameter and then I require to make a head, what process we will go for? That is offsetting in forging operation. So we need the die of specific successive 3 stages of die. Single stage is impossible to make into the hexagonal head. So then we have to calculate this material, you have to design the die, you have to rise the temperature and losses of during the heating and cooling of and impacting and hammer blowing, I think upsetting to make into this. So that you have to be very proper knowledge, very carefully, you have to be proper engineers, then you can. Now the question is become what material specification that you can select it for this particular offsetting process by forging. What is the Indian standard specification? Specification should be IS 107, that is called forgeable quality. If you selected IS 226, it is a machinable quality of homogeneous structure. If you striking by hammer blowing, micro crack will develop. So that is become a heterogeneous structure. Once it is striking, so that molecule will compact and increase the strength. In this way we can manufacture this shape, can material save the machining time and everything. Then we go for not thread cutting by changing process, thread by rolling process with thread rolling, and then go for heat treatment process to increase the up to 88 Newton per millimeter square of tensile strength. So that knowledge you should have to be there. So that's why I am telling you the total quality management and material requirement planning. So what should be the material requirement planning? Whether maybe expertise system, maybe computerized system. Then you can develop the manufacturing process. Then CAX, CAX and engineering tools. CAX is nothing but that it is 100% computerized manufacturing system. Computer integrated, internet based, web based, clear? Every parts with a use mobile simple. Mobile can operate the machine, operate the setup, operate the system, and can possible to manufacture. Even you can forgot your close your door. You go out from your door. You stop the light. You stop your fridge. Stop the television. You can also close it from the outside. Clear? Through web, cloud system. So that is CAG. So that type of advancement we have already ahead and stepping our leg. Second thing is BPR, business process re-engineering. So business process re-engineering and e-manufacturing. Clear? So here agile manufacturing. So here in that cases we have used the different things. I am coming, what are the agile manufacturing and all these. Next step you see, this is, what is, here you see lot of things here. Quick response manufacturing, global manufacturing, customized production, improve productivity and quality. Main things to improve the productivity and quality, satisfy the worker, satisfy the customer. That is become the with satisfaction of the employees. Clear? That is employees satisfied, the employee can give their more input. So that here also concurrent engineering and many more. Concurrent engineering, you know, I have written over here. This is simultaneous work, not a one by one successive. Simultaneously, design and manufacturing simultaneously will be going on. So that without wastage of time. So the modern manufacturing system process are basically flexible system, modern process of IC manufacturing, rapid prototyping, additive manufacturing, then 3D printing process and etc. Then I have to show you the e-manufacturing. What is e-manufacturing? You see here the e-manufacturing here. Many more things I have included over here. Supply chain management connected with the e-manufacturing with customer relation management. Supply chain management and customer relation management. Clear? Here, it is a e-manufacturing nothing but it is a system that introduced by the various researchers and manufacturers or entrepreneurs in the manufacturing operations to successfully integrate with the functional objectives through use of internet, use of wireless or web and productive technologies. I think very clear. Productive technologies and a lot of things are there involved. Clear? Just like a e-manufacturing enables high level of automation in the manufacturing business information rather than physical one. That means information flow and workflow simultaneously. Clear? Both of the organizations should be efficiently and effectively increasing and processing so that the customer can be satisfied and immediately take care to the customer requirement, demand and future aspect, that is forecasting. What the future generation will demand. Today think, India once was failure for that. Why I am telling you, earlier once we are student and engineering graduate or something else, we see the casting industries and there have a cupola furnace. Cupola furnace are dedicatedly used for casting of cast iron, IS 210, grey cast iron, even not malleable cast iron also, very difficult. Even spheroid oil cast iron. I don't know if people have idea or not what is the spheroid oil cast iron. If the material conference you people doing of that time, I will, if here I will be analyze all these details, so that what is become the materials and what are their importance. So lot of I can explain. So that industries all are failure in the industry because now no one is interested to use the cast iron. No pipe, no drainage system, no all these things. So then nowadays it's plastic, polymers and many more advanced material is coming. But that cupola furnace are have no utilized. No molding, no these are utilized. So all of even your Ludhiana and other circumference, even Hooghly river and Ganga river, either bank of the river have a lot of cast irons. Companies was locked. People are unemployed. Because the Indian people who are not thinking like this, what I am talking today, that should think the people for tomorrow. So what should be the industry? The industry today survive, even tomorrow can survive with the same infrastructure, only require some modification or some alteration. But in the casting foundry, basically those who are iron casting foundry, they are basically many of the foundries where only the cast iron deal with the cast iron product. They have all are shut down. So this is the become things today. So we have to the actual enterprise resource planning and as well as capacity planning with take care of the future requirement. Then we have to advancement with side by side the advancement in the manufacturing system have to be followed. So this is one of the important things. So I have written over here, terms of e-manufacturing means using electronic information in the manufacturing of a product. Electronic information. So that means, say sir, the process, our recent trend in additive manufacturing, you are talking like this. I am talking, you need to be about idea, what is manufacturing. Then you can automatically motivate it. What should be required for the future. So next, one type of manufacturing, all machine tools are linked to the internet. All machine tools, clear, are linked with the internet. A person can connect the machine with the laptop, computer, personal digital assistant, PDA, cell phone, or other device, anywhere through the cloud computing. With e-manufacturing, company can stay in immediate contact with suppliers. With the suppliers, anywhere, say world, any place. Customer are there, supplier is here, can be possible to this. And the company can manage different supplies of the same product and keep inventories up to the date using the internet. So that is a advanced manufacturing have then basically two characteristics. One is automation and high precision. That is most important, high precision. So e-manufacturing enables the higher level of automation manufacturing. Business information, enhance, improve the information and workflow, causes of increase the efficiency and effectiveness in the manufacturing. Basically, it is an internet-based technology. So now I am going to rapid prototyping, additive manufacturing and 3D printing. Clear? So I have to go for the another slides. I have to stop over here. Part 2. I have stopped here. That will give you again the idea of what is the basic actually in the additive manufacturing, because I cannot explain overall, but I given a overall like idea. That idea gives you what are the advancement in the manufacturing. That I think you clear here. What are the advancement? So now I am going to another things which will be important to you, that is
अब हो रहा है सब प्रेजेंट हो रहा है
प्रेजेंट हो रहा है ना?
हाँ जी आगे खोलो पीडी अपनी पीपीटी
हाँ खुल गया.
हाँ जी बस वो हो रहा है प्रेजेंट
हाँ ठीक हो गया.
हाँ जी
About additive manufacturing, trends and application. Then this is another important part I am going to this, particularly in the particular applications. So you will be see the what attractive are there. So then here see the rapid prototyping. So your actually theme in the particular short-term course. I think people are eagerly waiting for that. Say now half an hour or more, sir is talking lot of things. I am not talking lot of things. I am talking the basically most important things which is really not available of readily anywhere. That I am talking something, only few parts of this. Now I am going to the specific parts. So you see here, what are the development in this aspect? So in the 1988-99 and 94, that is rapid prototyping was started. 1988 rapid prototyping, you see from this graph. Then 94 rapid casting, 95 rapid tooling, and 2001 additive manufacturing for automation. Then 2004 aerospace, then polymers engineering, sometimes so-called people. 2005 medical, polymer jigs and guides. 2009 medical implants, dental basically of the time used. Then 2011 aerospace, again metal. 2004 polymer used in the aerospace. In the metal part is used through additive manufacturing, is manufactured or produced and then used in the aerospace engineering. Then 2013 to 16 nano manufacturing. That is the most important part. Then 13 to 17 in architecture. I am coming one by one. And 13 to 18 biomedical implants. Then 13 to 22 in situ biomanufacturing. And expected up to 32 full body organs can be possible to manufacture by using additive manufacturing technologies. That trend, history, the engineer should know at least. So the rapid prototyping is a modern manufacturing technology, obviously. that is known as desktop manufacturing or free from fabrication. In this process, a solid physical model of part is made directly from a three-dimensional CAD drawing, computer-aided drawing. Rapid relative means it is with respect to some things. So that therefore in that cases say that the product may be required the several minutes, hours or a day depending upon the methods used and size as well as complexity of the model. That is challenge today. How you reduce the time, how you design the nozzle, how you use the material, what should be the temperature during curing, or what should be the temperature you making the melting of a metal part or powder when you put layer upon layer on a substrate. What should be the substrate should not be react with this, so that easily you can dismantle the substrate from the product or from the part. This is the challenge today. Clear? So, so now, what are the basic principles of rapid prototyping? A solid with prescribed shape, dimensions and finished product can be directly produced from CAD-based geometric model via data store in a computer without human interaction. Simply you make a program, take the data and then make it. So this technology is called generative manufacturing process, GMP. And as a shape of workpiece is not obtained by the several chips or forming or casting, which is not possible by this. So it is achieved by additive of metals without any prior recognizable form or shape, or no tool is necessary. Clear? So that CAD model, first CAD model basic principle of generating, you should make a CAD model in the 3D printing or 3D dimensions in the computer screen, you see it, then slice into different layers and then generating layer upon layer. That is the basic principle. So here I am just showing here CAD model. First you generate the CAD model, various softwares you know, I think. You first generate it, what type of you want to part manufacture. Then triangulation using the standard tessellation language software, that is called STL interface. You use this and you make it into a genetic support structure. That is pre-processing process. Then slicing into, say that is layer might be a 300 microns. I want to deposit a 300 microns on a substrate. Substrate, I think you will know, just like a chips of prototype, made of silicon oxide or something else. And then I want to deposit the material of semiconductor, conductor or whatever may be the material I want to deposit. So that 300 microns, I have to decide the layer thickness should be say 25 microns. So how many runs or passes, just like a welding, what should be the bubble? If they are having any your defectives, might be it is not a properly gap, or sometimes due to solidification is a micro crack or deformation, or the dimensional lower, then you have to use a sort. Sort, I think you understand? SHOT, sort. Sort is a small of same material ball which will become strike on this particular area, and then you again deposit this material called sintering. Not in the powder metallurgy sintering. I think heating and compacting is a common sense of the sintering in the powder metallurgy process. Here also use of same thing. So this pre-processing layout of the generation process, first you have to create it. Then you going to generating the manufacturing process. Then you come to the post-processing process. Required to clean, required to post-curing, then post-working and finishing, then component and pattern product involved in this. So therefore, slice thickness and slicing directions can be varied for convenience of the generation. Which exactly you want to generate, what directions your nozzle will be very easy to move. In this direction you have to move it. Clear? And generate object the same shape that of the slicing in the CAD model. So that the commercially developed and technically demonstrated your GMP, generative manufacturing process, is used to develop a part by slicing technique. Then the direct 3D building of technique, no necessary to define the part in terms of thin layers, and the process will not require to generate of lower part before the upper part being generated if you want to make a complete 3D project continuously at a one setup. So then first you make the drawing here. This is a drawing here you first made, and then drawing going to the CAD help of that, and classical technology also used over there. From here RP technology, rapid prototyping technology, then follow-up technology, then prototyping. After that it will be on two parts. If it is some defective found, then manual modification, revise, and then further CAD, then recycle. Otherwise it is come to the quality assurance, evaluation, validation. Over there during valuation or cost analysis might be too cost or might be some defect in the testing and quality control, then is returned back again to this. Clear? Or otherwise product to be manufactured. This is the simple flow diagram. So now the prototyping technology based materials, one is selective laser technology, SLS. Thermoplastic materials, metal powders can be used. Next is direct metal laser sintering, DMLS. Alloy metal, most cases are alloy. I think you will know which one is alloy, which one is pure metal, which one is composite, which one is amorphous, and many more in metal. That is, of course, you people are going to conducting this material, advancement in the material, that is most important for the engineers. So now the fuse deposition modeling process, thermoplastic, eutectic metals, stereolithography, photopolymer, in that cases we will use photopolymer, laminated object manufacturing, thin metal paper or plastic film we can use, electron beam melting, that is titanium alloy, 3D printing, and plastic, polymer, etc. can be used. Solid free from fabrication, SFF. Solid free from fabrication is an application of a set of techniques, for manufacturing of solid three-dimensional object by sequential delivery of energy or the material in the particular specified point, whether it is in powder form, whether it is in the melting form, clear, or used as a wire, or otherwise in the your particulate form to spray with some injector. Might be it is a hot air injection in a vacuum chamber. I think understand? We have developed one of the vacuum chamber with a hot air, or one of the PhD student, and completely developed this material. Anyhow, electron beam machining, melting, fully fused void free metal parts from powder stock. Our electron beam free from fabrication, fully fused void free metal parts from wire feedwork. I think you understand. Next is fuse deposition modeling, that is deposits the modeling extruded hot plastic through nozzle, building up of model. Next is laminated object manufacturing, sheet metal, paper shape or plastic film are attaching layer upon layer by either sprayed glue, heating or embedded achieved, then cut outlined by laser or blades. Whatever with the more extra part, it will cut by blades. Finished product typically, not topically here, typically looks like a plywood. Clear? Like a plywood. Then laser engineered net sets. So here a laser is used to melt metal powder and deposited it on the part directly. And in this case, solid layer can be added on the part and change the metal composition over the part. How it will become? So the metal part may be used as a wire or may be used as a powder. Powder first spray on the bed. Bed is a certain platform. I will give you the picture. Bed is a certain platform and used as a roller. Roller is moving and forcibly move the powder towards the actual location where the laser beam is concentrated on it. Laser you can generate it by using the power of lens properly, concentrated in the particular point and maintain the proper distance, allow to melt by making in the proper temperature. So that is also challenge today. Next is selective laser centering. In that case, you fuse the powder of nylons, elastomer or metal and curing by this powder form by again laser beam. Safe deposition modeling, manufacturing. Safe deposition is a part and support materials are deposited by a print head and machine to make near safe product. Next, solid ground curing. That is also ultraviolet light is here in that case is used. I think you will have an idea. Ultraviolet light is used also permeability test in the foundry. Greens and mold permeability test. So that type of ultraviolet light lamp you can use in the electrostatic mask to cure a layer of photopolymer. So use solid works basically for support in that cases. So next is stereolithography used to laser to cure the liquid photopolymers. Three-dimensional printing. In that cases process use inkjet printed deposit materials in layers. It includes thermal phase change inkjet and photopolymers phase change inkjets. Just like your printer, inkjet printer, 24 pins or like this way. Now, robocasting. Robocasting refers to deposit the metal from a robotically controlled syringe or extrusion head. Robot will maintain with the syringe, just like injection like this way. Then pad printing. Pad printing is a printing process that can transfer a 2D image into 3D object, solid object. Image being transferred from the printing plate via silicon pad on a substrate. And pad printing is used for printing and deposit functional materials just as conductive, inks, adhesives, dyes and lubricants. Clear? In that case, physical change within the link film both on the printed plate and silicon pad allows it lead to the etched image. Etch means etching. There have a chemical etching, there have a dry etching, clear, and there have a liquid etching, clear. That is in solid phase, also can possible. You make this particular area, other area you cover by a mask, and that area you require to remove a specific cavities or channel. Say in the nano level, can possible to the etch by use of some chemicals on this particular area. Next is pulp forming. It is a continuous process. Nothing but that, it is a constant cross sections are made by pulp forming process, just like a seed. Simple, just like a leaf spring. You want to make a micro level, miniature leaf spring, not in the track types, leaf spring or all this. Clear? So, additive manufacturing refers to a process of digital. Now I am talking of the additive manufacturing. 3D design data used to build up a component in the layer by deposition materials. Clear? Here in that cases, you see the use the data computer aided design basically. So software and 3D object scanner to direct hardware to deposit materials layer upon layer in precise geometric shape that you have drawn first using the computer aided design. And the additive manufacturing known as 3D printing because it is a transformative approach to industrial production that enables the creation of lighter and stronger part in systematic way of three-dimensional object or product. Clear? Our terms 3D printing and rapid prototyping are usually subset of the additive manufacturing. Clear? So additive manufacturings are, you can classify like this way. So there have a basically two parts. One is liquid, another is powders. Two base material are usually used. Liquid phase, usually in metals, polymers, But in the powders, usually in the ceramics, liquid is very difficult. You know the ceramic, say silicon carbide is a ceramic. What is the melting point of ceramic? Silicon carbide. Have you idea? What is the melting point of alumina Al2O3? 2072 degrees centigrade. Silicon carbide 2750 degrees centigrade. So thereby it is very difficult to melt even by the laser, because we will use the laser here very low temperature laser. So in that cases we will use the ceramic powders. Then liquid phase the photopolymers and molten metal. Here in that cases cure via vector scanner, that is called laser. Another cure via raster scanner, that is called projection. And cure via lamp, that is ultraviolet lamp, are used in that cases the stereolithography SLA or DLP, digital light projection, or another multi-jet modeling. Another is the molten materials, the extrusion and ink jetting, that is fuse deposition modeling, or otherwise you can drop on demand. Once it is flow like this way, so it is a nozzle that is on demand by a vacuum system. Partial vacuum is become created so that can suck and drop on the layer, which is be predefined based on the program. I think very clear. So then you can maintain overheat. So that in the way, again, powder bed fusion methods, fusion by the electron beam, or fused by the laser beam, or fused via binders. Clear? In that cases, even coaxial laser deposition method, also laser metal deposition process can be used. But the metal cases, I have general cases advertised, but in that cases the metal additive manufacturing process. Metal additive manufacturing process, first category wise you can define powder bed base, direct energy deposition base, then solid state base, then feedstock base. One is the powder, then wire, then foil, again powder. The powder is selective laser, electron beam, and blown powder deposition process, that is direct energy deposition process. Or wire arc based deposition, electron beam deposition, ultrasonic additive process, Fixton STR additive process, cloud spray process. So these are the different processes. Now how does the additive processes working? That is again another important point. The term additive manufacturing refers technologies that grow three-dimensional objects, one superfine layer at a time, and each successive layer bonds to the preceding layer of melts or partially melted material. Objects are digitally defined by the computer-aided design software, and that software is standard tessellation language used in the stereolithography files. Slice the object into ultra-thin layers, and information guided the path of the nozzle or print head as it is precisely deposited material upon the preceding layers. So here additive manufacturing process, a powder bed fusion process, binder jet process, direct energy deposition process, I have already explained it. Next, material extrusion process, material jetting process. Next is sheet lamination process. Clear? That is two sheet laminated method. That is LOM. Use alternate layers of prepar and adhesives. Clear? Next is vat polymerization process. Object is created in a vat of a liquid resin photopolymers. Clear? That is photopolymerization. Curing each microfine layer by layer using ultraviolet light, precisely directed by a mirror. That mirror is properly directed exactly the location and striking. Now sintering, direct metal laser sintering process. So direct metal laser sintering process here in that case is laser sintering each layer of metal powder so that the metal particles adhere to one another, and machine is reduces high resolution object with desirable surface features and required mechanical properties. Next is direct metal laser melting, electron beam melting process, and stereolithography process. So then additive manufacturing materials. What are the materials are here? One is thermoplastic, say acrylonitrile, butadiene styrene, that is ABS. Usually we will use helmet, manufacturing of the helmet. That material is renowned for use of this ABS, helmet manufacturing material. So that is used. Then metal precision like gold, silver, etc. metal can be used. Ceramics, zirconia, alumina, etc. can be used. And biochemicals also can be used. That is a hardened metal, that is silicon, calcium phosphate, zinc, etc. Biomedical, biodegradable zinc, that can be also used. Now the material for additive manufacturing, say laser additive manufacturing here, the partial melting of powders, complete melting of powders. A laser sintering, there is a partial melting, that is pre-spreading of powder before laser scanning. That is multi-component metals or ex situ metal matrix composite. Whereas here the complete melting of powders, one is laser melting, another laser metal deposition, another is pre-spreading of powder before laser scanning, or coaxial powder feeding with synchronous laser scanning, pure metal powder, or otherwise alloy powder, otherwise ex situ or in situ metal matrix composite. Here titanium, tantalum, copper, gold, silver, etc. can be used. Titanium based alloy, nickel based alloy, ferrous based alloy, aluminium based alloy, cobalt based, copper based alloy also can be used. Now the question is become today also in the your beginning inaugural ceremony, I also told this material knowledge is very much important. If you talk about this, sir, I want to only knowledge additive manufacturing, 3D printing. So when you are going to select the material, you should know the characteristics of the material. What is the melting point first? If I asking you what is the physical properties of a material, can you be able to give the answer? That is very much important. That is the challenge today. What are the physical properties? How can change the physical properties? You can change the mechanical properties by heat treatment and many processes. But how can change the physical properties? That is the challenge today. If I not do, so how can talking about the advancement in the manufacturing process? How can make it? I think you understand. A lot of things are there. So manufacturing actually it is a master of trades of all subjects. You must have a thermal knowledge. You must have your other strength of materials knowledge. Must have a design knowledge. Clear. Must have a material science knowledge. Then you can make a manufacturing engineers. Otherwise you never manufacturing engineers. Because you have to defeat the metal characteristics. You have to defeat it. I can defeat you if I have more knowledge than you. Earlier sword was fighting. Clear. Brain plus energy, capacity. कितना शक्ति किसका पास है? But अभी वो नहीं है. अभी Japan very small. They have a population is very small, but they are rising because of this. That means we need the knowledge so that I can rise on this particular material. Then I can deform, can change the shape of this material. Then I make the appropriate shape and size of the product, utilize the suitable acceptable material. And you have to generate the acceptable material, appropriate material. If you are not able to generate, then you not even the engineers. Then you have to search alternative material, and because of shortage of material, you stop your development. That is India today. So that we need to process it fast. How you generate the material, how you understand proper characteristics, behavior of the material. Then you apply the process to dominate that behavior and characteristics of material and make it towards actual desirable or desired deformation. So here material use in a additive manufacturing. Material use, their powder metals is only 1%, other metal 1%, and thermoplastic powders are only 2%, whereas photopolymers use is 56% and thermoplastic 40%. Now many of the engineers have no idea what is thermoplastic materials, what are these, what are the characteristics, and photopolymers, what are the photopolymers. So can I generate some materials of similar characteristics of the photopolymers? Clear or not? So that is important. That challenge is required. So basic principle is this. You see, first slicing. This is a slicing with the 3D CAD model. Then this is the slicing part. Then hatching. Then you as a hatching distance. That is two things. Slicing is the vertical height gap between the two layers. Whatever the solid object you want to make, you make to slice of lines with a gap of say 25 microns, 30 microns, or 40 microns, not more than 50 microns. So that kind of, then you have to making like this, and then parallel this thing, that is called hatching. That is hatching also distance. Then you can make layer a layer, one layer. Then what should be the gap with the other layer, so that one layer can detach with this other layer. Not only this, but also this in the X and Y direction and then Z direction. I am coming one of the program I will show you so that how it will become generated. So next is become अच्छा कितना टाइम हमको मिल सकता है 10-15 ओके आई हैव टू वन ऑफ दिस आपका संत लोंगोल में 2005 साल में आई थी 5 और 6 मैं 8 बजे शुरू किया था
ओके
इवनिंग में खत्म किया तो बच्चे लोग सर खाना नहीं खिलाया देगा हमने होगा ऐसा ही है एनर्जी क्योंकि ये जॉब ये सब चीज इतना इजी से तो खत्म नहीं होता बहुत सारी चीज है यार अगर मैं तो एग्जांपल नहीं दे रहा हूँ एक एग्जांपल में आई हैव एंटायर माय सेल्फ आई एम एंटायरिंग एग्जांपल इट इज वेरी डिफिकल्ट टू कंप्लीट दिस एनीथिंग सो here I think you understand how it is and how become it is. Next phase is the STL file generation. That is most important thing. So that is it is a file format built in the stereolithography craft software created by 3D system. So it is used I have based on this code, whether it is a binary representation or otherwise ASC and II based on this, whether 01 or something else. So that 3D printing software, that is another important point. What are the software? How you can use as a trial basis or otherwise procurement. So that is Autodesk Fusion 360, Autodesk AutoCAD, Ultimaker Cura, Tinkercad, MeshLab, FreeCAD, etc. These are become the software used. I am showing here some the software used in the additive manufacturing. I am showing in the tabular form. You see clear material, simulation and software. Next I am given a program and examples. You see here CAD model, that is a case study you can say. So STL uses triangle to describe the surface of the build. Each triangle is described as a 3 point and a facet normal vector indicating the outward side of the triangle. Here you see simple triangle here. Here is a simple triangle. This is a triangle. Clear? Here I have a solid point print. Facet normal. Normal is a center point. 0, 0, 0 coordinates. Clear? 0, 0, 0 coordinates. And then that is a center. Here not center here. Here center is 0, 1, 0. So coordinates 0, e to the power plus 0, 1. Middle point and the last z-axis point is 0. Next you see the your normal this and the outer loop. This is outer loop point and outer loop point. So outer loop point is 0, 0, 2. So 0, 0, 2. E to the power plus 1 because of point is there. There are some height. Very simple things. Very simple things you generate it and then you can easily. Next you turn over in this way. In the clockwise direction. Then you come to this point 0, 0, 0. Then the middle vertex point 0, 0, 0 coordinates. You see? There is e to the power also 0. Clear? Next you turn in this way here. This point. That is x, y, z. You just turning this axis like this way. This is one of the axis, another axis and another axis. 3 axes. Then you will find third point 1, 0, 2. That is 1.00 e to the power 0.1, middle point 0, 0 and this. Clear? Then you turn it like this way clockwise is considered and this axis will be anti-clockwise. Then you will go to this point. You will see this is, here point will be 1 0 0, here 0 0, it will become the 1 0 2. Here it will become movement of like this. So that is become the program. Very simple program. You make it this program and then easily you can run it. Just so the advantage I have also told you, that is provide the simple advantages and de facto standard and has been used by most CAD system and RP system. Disadvantage is many times larger than the original CAD data file. Next is one of the important file. You see, there are STL file problems. How will become generated the STL file problems? Here you see, say gap, cracks, holes, punch, etc. missing facts. Degenerate the facts here. First you see, here this is a surface 1, surface 2. That is a surface A and B. I have designated it. That is surface A, surface B. That is cell pictures eliminated at the expense of editing degenerate facts. Clear? Then you see A and D like this way. I am giving you, showing you here. You see a valid 3D model, slicing model, conversion 2D, then you become additives and then invalid model, and that is become layer of, and this is invalid model. If you make such kind of valid model, that is invalid. It will not become accepted for additive manufacturing. There it is a how you repair this particular file. You see here, say dekho 3, my cursor is here, 3, 11, 9, 7, 5, then 2 here. 3, 11, 9, 7, 5, 2. Ever you clockwise movement 3, 11, 2. That is 3, 11, 2. That is generated. Anti-clockwise movement of this and clockwise movement of program. So then you see again clockwise movement 11, 9, 2. 11, 9, 2. Clear? Similarly 9, 7 and 5. 9, 7 and 5. That become gap, so this part will become this. Take similarly this way, fourth phase fact of the your generated curves. Clear? Then features that represents the problem using CNC machine. Here, if you want to make this particular curve by the CNC machine, lot of problems are there. Sharpness, curveness, clear? Understand here. So these are the lot of axes you have to program, movement of the axis. Even CNC, if you use the diamond tool, one of the polycrystalline diamond 20 milligram coated tool cost is 1.5 lakhs. Understand? 1.5 lakh. 20 milligram. RO polycrystalline diamond tool manufactured using clay. Clay is taken from Punjab to the Japan. Understand? We are engineers in India. From Punjab, a bucket of clay, valuation you understand? They people design sandwich and others, and they people send to the India. India people will purchase it because the researchers as a guide of the PhD student, then PhD student have work on it. Anyhow, so this is generating AD process. First one CAD, second one STL converter, third one will transfer to the machine, fourth one is become machine setup, fifth one is become build, remove, then post processing and then application. Clear? So this is full phase application. But if you use in the additive manufacturing process, you will see here AM process. This is first layer upon layer build. You see layer very clearly, you will visible in the layer here. Effect of build using the different layer thickness. Then there and ultimately we will go to the finish. Clear? So then what drives the quality of the cost effect in the manufacturing? In that cases, you see material is 26%. Indirect cost is 74%. We have to reduce the indirect cost. Otherwise, till today, the additive manufacturing 3D printing is costly. Machine is not too cost. Our student is developed already 2-3 types of 3D printing machine. Abhi submit kiya PhD. Here, I'm showing one of the picture, just last slide. So then, it is not to cost. Cost is the indirect overhead cost. So the overhead cost here in the your 59% and others is indirect cost is 74%. So here I am showing the break-even point. I think you people have an idea what is break-even point. So here you see the additive manufacturing cost is increasing when you increase the quantity, whereas traditional cost is decreasing. That is the reverse. We should make into as traditional so that we can make more quantity, we can earn more profit and acceptable or easy to access to the customer. Customer afraid about the cost. So we want to easy to access to the customer, we need of this thing. What is the pros and cons? Advantage, disadvantage. So freedom to design and innovate without penalties. That is advantage in case of additive manufacturing. Rapid iteration design through design and permutations, excellent for mass customization, elimination of tooling, green manufacturing because there is no gases, no carbon dioxide, no others emission gas is released over here. But yes, there is emissions of the gas release when laser beam is striking on specific some of the metals and polymers. Clear? Still it is, if you want to manufacture white metal, I have no more much time, so I am not giving this. But here lead, you have one of the component. So lead fumes is very dangerous. Clear? Similarly, zinc साथ magnesium. If you use the zinc magnesium powder, use the additive manufacturing process 3D printing with laser striking on the powders of the zinc and magnesium. Clear? Then magnesium is before melting, it will become burning and discharge fumes. I think very clear. So that protection will require the nitrogen atmosphere. Clear or not? So these have become the drawbacks and you have to take care and advancement is required. So that's why it is lack of industry standard, low speed, not suitable for mass production cost is too high, limited number of materials, high equipment cost for high-end manufacturing, high process cost, unexpected pre and process equipment is required. If you want to clean it, very difficult, ceramic cleaning. Ceramics, if you want to ceramic powders used in product of any part through additive manufacturing or 3D printing. But cleaning surface, once you layer upon layer, some rough surface may generate during the processing of fuse deposition modeling or otherwise stereolithography process. Of that time, once you want to remove, any mechanical tool will not serve your purpose to clean or smooth the surfaces. Even abrasive flow finishing process are also not. Then we have to go for a hybrid process. I am not discussing now this, that is also, I have developed many of these hybrid process. So anyhow, so this is the weight reduction traditional design, additive manufacturing optimization design. First, conventional seat bracket weight is 155 gram. Now, titanium bracket design or additive weight only 70 gram, reduction of 55 grams by using. So here in that cases, complexity for free in additive manufacturing and with the cost is increased. So you see dental crown additive manufacturing holds a large share of the dental crowns and bridge market. And additive manufacturing offers advantages with regards to the manufacturing time, geometric fit and materials. It is automatic manufacturing. So man, not sophisticated, high skilled, even not required, but program is required high skill. Clear? So anyhow, I am not going to, last I am going to 3D printing, few slide I want to show you. So that is have a 3 CAD modeling and to manufacture of like this way. Clear? Can possible. Anyhow, I will going to another important things, that is 3D printing. That is uh, 3D printing. 3D printing, your additive manufacturing or 3D printing is a process of making a three-dimensional solid object of virtually and saved from a digital model. Just like I have explained, the e-manufacturing, people are thinking it is a virtual manufacturing. No, not manufacturing is virtual. Clear? Not manufacturing. E-manufacturing is not virtual manufacturing. It is only successfully coordinate the internet, wave, clouds, clear, and productive technologies correlate simultaneously, so that can improve the effectiveness and cope up, take care of the problems of the customer, immediate action. So customer can satisfy. So here, take similar way, this virtual is saved from the digital model. 3D printing is achieved using an additive process where successive layers of materials are laid down in different shapes. 3D printing is considered distinct from traditional machining techniques, which mostly rely on the removal of material by methods such as cutting or drilling. No required of subtracting. That is deposition. One is top-down approach, another is bottom-up approach. So here approach is bottom-up in the micro manufacturing process. Bottom-up approach by deposition of the, whether in the liquid form or whether in the solid form or whether in the semi-liquid form or in the powder form. Clear or not? Making a particular path in a pass, number of passes based on the mechanics of the design and program. So that the fuse deposition modeling, selective laser sintering, stereolithography are the most widely used in the 3D printing technique. You see here, there is a nozzle, and nozzle is become, we have designed a nozzle, of course, the nozzle is made of tungsten, clear, with the 200 microns of the initial from mixture hole, and after that it is 50 microns of hole, clear, and that 50 microns of holes are allowed to demand on drop of liquid metals on the substrate, clear. So these are one of the pictures that I have developed, and this is the fuse filament fabrication, selective laser sintering, fuse deposition modeling, stereolithography. I have also explained many times. Many different metals can be used in 3D printing, such as ABS, I have already explained you, plastic and nylons, glass, polyamide, and stereolithography materials epoxy resin type, that is silver, titanium, steel, wax, polymer, polycarbonate, and chocolate and clay rough. ABS already I have told, the acrylonitrile butadiene styrene, helmet material basically I have told you. All helmets are made of ABC materials. It is a, you can say, branch structure which is more stronger, and density depends again on the structure also, 0.62 to 0.97 gram per cc density. So application of the rapid prototyping you see here, one is automotive, aerospace, customer, medical, industrial, and research. Stereolithography material are polymer, and you see ceramics. Here I have shown. Then laser sintering, one is materials and alloy, another is powders. Clear? then selective laser centering metals and alloy, then fused deposition modeling, polymer, thermoplastic, ceramic and glass. Clear? So, industry product development, tooling, micro electro machine, clear, development of this. Then manufacturing, that is fabrication, micro fabrication, architecture, building design, bridge design, recovery. Collapse you can recovery by this way. Then rehabilitation, surgical planning, then diagnostic, reconstruction, drug delivery. Then others, artifacts, duplications, mapping of 3D, cultural reliefs, restorations. Now, what are the problems? Okay, problems about part accuracy, mathematical error, including facet approximation of the part surface in the standard input to the RP and M system, rapid prototyping and manufacturing. Now, clubbing both the system. Again, it is advancement. Rapid prototyping and manufacturing, RP and M system. Clear? I have written one complete chapter on this RP and M in advanced manufacturing technology. It's coming in the books by 1 or 2 months. So then next is become process related error effects. Process related error effect. The shape of layer in the XY plane and Z direction. It is because of, say, might be distortions or deformation during solidification. While it is become striking of laser, it is in the core, it is in the liquid phase or semi-liquid phase. Once it is solid and attached layer upon layer with the others layer, some part is more contact or more cool rather compared to the other. If you use the alloying element while you making some semiconductor or other product for diode or triode or semiconductor bulbs. Clear? Or rectifier. What is rectifier? देखो भाई हम पहले बोला था engineer mechanical manufacturing engineer is a versatile. He should be electrical engineers, should be a civil engineers, he must be a design engineers, must be a thermal and your heat transfer engineer. Very good. Then can only a successful manufacturing engineers. Even material science also have a very good knowledge on material science. So rectifier nothing but that is two-way valve of AC convert into DC diode. Simple. That we have to be manufactured by this way. In that cases, with using this smart material. What is smart material? That is only change of, say, temperature, change of pressure, characteristics automatically changes. Just I will explain whenever next time. So then the material related problem basically I have also told, and during the building part of stresses due to shrinkage may be lack of these particular parts. Clear? So the potential industries in the additive manufacturing are here you see, that is the different products, that is in electronics, in food, in automotive, in implants, in surgical, even in textile, even in prosthetic, toy, sports equipments, electronics equipments, all areas the additive manufacturing can be possible to apply. But you should know the how and what material, what should be the temperature, what should be the process of the speed of the nozzle, what should be the height of the layer, what should be the your gap between the two layers, ditching. Clear? So their materials are metal alloy, composite, ceramic, carbon fibers, engineering plastic. Nowadays use the carbon fibers also. Clear? As in reinforcement of there. And the stainless steel and tool steel, titanium, aluminium, other materials are also used. Now some of the question is here, if you want to mix, say, your tin with the aluminium, Some of the cases we need to mix the tin with the element. Okay, here I will stop. So because you people are hungry to this, we will go to. So in that cases, one of the important thing, tin has only melting point of 232 degrees centigrade, whereas aluminium 660 degrees centigrade. I think you understand what I want to say. How you mixed it and how you become making with it. And if you make it the melt of the aluminium, in the meantime tin will start to vaporize because 480.5 degrees the vaporization temperature. So your head should be a mini dictionary of the properties of the material and their characteristics. It should be stock so that you can work on it. Okay, then we can stop now. So that these are the different things of these parts. Even we can use the alumina turbine blades and impeller. And this is exactly generation and these methods of 3D printing. Good day. Any question?
Sir, as you already told that generally for the manufacturing of any additive manufactured components by material zinc and magnesium alloy, you used N2 environment, nitrogen environment. But in most of the literature, they used argon. So I want to ask that which one is better, argon or nitrogen?
Argon gas you can protect only against the oxidization. Make a layer protect against the direct contact of the atmospheric air in the working atmosphere. Argon atmosphere cannot make a low temperature with working, but nitrogen can maintain a low temperature, and the that cases I can maintain the temperature inside this chamber of the or furnace, whatever may be with. But you can perform this just like argon. You know continuous casting, I think you will have read it. Continuous casting, with the use of some of rollers and then oxycart to cut into a separate part. By you want to say channel, you want to make the railway track by the continuous casting or forming process. Clear? So in that cases we can use the argon gases because of make healthy atmosphere without directly attached or make a layer on the working zone which will gives the protection from the oxidization from normal atmosphere. That is only this. But nitrogen makes two things. Whatever may be oxygen will come immediately form some nitrogen oxides. Clear? And will become moves out. And nitrogen makes a inherent temperatures during the chemical reaction, and that temperature not moves outward direction, it is moves inward direction to the reaction phases. So outwards gives a protection, inwards rising the temperature. We need to rise the temperature, make the melt both the things, and as well as outer atmosphere protect from the oxygen so that it will not be itself is your burning or help or to hesitate to burn. I think clear now. Motivate to burn. That will protect. Both the things we need in that cases once you work the magnesium. हमारा एक बार विजिट कर लीजिए हमारा लैब कभी आइए. एक स्टूडेंट 2012 साल में पीएचडी किया, उन्होंने एक फर्नेस हमने डेवलप किया that is resistant heating furnace for magnesium melting. Magnesium used as a metal matrix and composite we have developed magnesium. 2012 साल काफी पहले. ठीक है.
Anybody else from
any और more questions?
सर एक क्वेश्चन.
हाँ बोलो.
जैसे मान लीजिए अगर मेटल का या एलॉय का हम एडिटिव मैन्युफैक्चरिंग करते हैं, तो स्ट्रेंथ जो है वो किसका ज्यादा होगा, नॉर्मल कास्टिंग से जो प्रोडक्ट तैयार करेंगे उसका या एडिटिव मैन्युफैक्चरिंग का? क्योंकि ये जो लेयर बाय लेयर डिपोजिशन है तो मे बी चांसेस है.
नहीं, here one of the important things is normal casting. Then if you cast it in the alloy, clear, so that once is very difficult to make into a complex shape. Manufacturing is very difficult in casting. You have to go to the investment casting. I think understand what is investment casting. So that is complicated cost, expenditure and complicacy for a small product or even a mass production impossible by casting, because you have to every time make a become your mold. Clear? That is one of the things. Second thing, I have just told you, even just white metal, I have given you one of the examples. There are three components. One is tin, lead and antimony. I am not going to discuss in all details. But what is the basic temperature? Antimony is 630 degrees centigrade. Clear? Tin I have already told, and lead is 327 degrees centigrade. I think you understand. So therefore, if you want to make the tin, in the meantime, antimony will not become melt. Tin will start to vaporize. Clear? And this weight, as far the weight is concerned, tin is heavier than antimony. You understand or not? Antimony is 7.32 gram per cc, tin is 7.32 per cc, 7.32 gram per cc tin density, whereas antimony is 6.69 gram per cc. Your head is always will become a mini dictionary. I have just told you. Clear? Whereas lead is 11.3 gram per cc. I think you understand. Mila lena jo main bata raha. So therefore, there have a lot of complications in this. But here in that cases, that complexity can be overcome. But strength as it is, strength is no at all in minimized. We have tested and identified it. Clear?
Anybody else?
Any or more questions?
From the online participants, if you have any questions, please put into the chat box. We'll wait for one. Or raise your hand.
What is the questions?
Yes, sir.
Ramesh Babu?
So it is not the question, sir. My request is, sir, some of the slides you have provided your slides. So if you share those slides, we can go through those things, sir. That's my request.
That already I have given over here. One of the part I have
Okay,
given,
thank you,
that
sir.
is given, the maximum slide is there.
Okay, thank you, sir.
Anybody else? Okay then.
Okay, can I left?
Yes, sir.
Okay.
You can. No, don't leave. Don't leave.
Oh.
Just give. No issues. Close.
Hmm.